and share the screen. What was the last topic? Can anyone help me?
5.4, sir, math, tariff.
Yes, 5.4. That means that we are studying the tariff mathematics, okay? And we are discussing the two-part tariff system. Probably this was the last mathematics. No, 5. Not 5.4, 5.5. Have we discussed this?
Yes, sir.
Yes, we have also discussed this. The main theme is that, to design a tariff system, probably we have two parts. One is the maximum demand that you are demanding, that how much kilowatt I'm demanding. For that is for one part of charge, your tariff charge. Another charge is the for the the running cost. That means that amount of electricity, the amount of unit of electricity you are using. So you have to pay for that also. So this is the two-part tariff system.
ম্যাক্সিমাম লোডের যে কস্টটা যে আমরা ধরি ওটা কি হচ্ছে যে ফিক্সড কস্টের জন্য নেওয়া হয়?
Yes. In our country, this amount is very low. Yes. You will also see that the demand charge. Have you, if you check your bill, electricity utility bill, you will see the demand charge. And also, if you are using the prepaid bill, you will see, suppose you are recharging 1,000 taka, a certain amount of money has been taken. Have you faced any this kind of thing?
আমি কখনো পে করি তো বলতে পারছি না।
Okay, you better ask that person that who have been dealing with this system. So better, if you are using a postpaid, there is a particular amount that is denoted as the demand charge. Okay, so that is taken every month from every customer, that is taken for the fixed cost. That and another one, those are using the prepaid bill meter. If you are recharging 1,000 taka, a certain portion of money has been cut off, and the rest of the money you can use for the electricity purpose. So, and also there are different distribution company. It will not be the same, because different distribution company has the different different amount of cost. So the tariff system will not be same for all company. I have shared the Pulli Vidyut Samiti, my company. Probably if you are under the different company in Bangladesh, it might be different, because the tariff system only determined the company you are taking. Okay. Today we will start from the 5.6. My student, this mathematics is very big, but don't get frightened, because it's not tough. Probably the question is very big, probably the solution is very big, 3 or 4 pages, but it's very easy. Probably you can get frightened by the volume of the solving, but it will be very easy. Trust me. Just see my explanation and just match it out. So we said that a generating station, probably this will give you the idea of from the generating station to the consumers, all station level. The electricity generation starts from the the generating plant. From there, that electricity is then traveled by the transmission line and goes to the substation. Substation is that region or that part that in between the generation and the distribution. So at that the substation is in between. Just the substation is established for the changing of the voltage level of the power level. Suppose in the generation level, we all know, probably you have studied, the generating voltage is probably 15.5 or 33 or 11 kV. But when it goes to the the distribution, okay, can you help me, anyone, that what is the distribution voltage, my student? Anyone? What
Yes, sir.
Yes, please tell, what is the transmission voltage?
Transmission voltage.
Yes.
Transmission voltage may be vary. Maybe generation voltage is 11 kilovolt, and it can be 100. It's step up 132 or 660. Then after when it comes substation, it will be 33, and further it will be 11. Then 11 will be distributed to the big customers. It's 11, and the small consumers is 400. Further step down, and it will be 440 voltage or like this.
Okay. Everyone is clear about this voltage level, my student? Everyone is clear, or I need to talk a little bit? If you want, I can talk, or everyone is clear? My student, it's very
Clear about
important. Everyone is clear? Everyone is clear about the voltage level of different sections? At least give a feedback. So no, sir, we are clear. No, we are not clear.
sir, clear.
Okay, then I don't need to talk about. Probably you have studied. Okay. So basically, my student, the generating voltage is probably 15, 11, 33. It depends on the generating plant. It is not a fixed. It is not a fixed, my student. Generating voltage is not a fixed, but some regular voltage is 11 kV, or it may be 15 kV, or maybe 33 kV. It depends on the generating plant. But when you transmit the voltage, it should be the grid voltage. It should be the grid voltage. You cannot change your voltage level, because in the national grid in our country, there are right now there are three voltage available. One is 132 kilovolt, one is 230 kilovolt, another one is 400 kilovolt. So these are three transmission voltage available. So in any transmission level you can use. So for that, in the generation section, the transformer, it is a step up transformer from 11 kV to 132 kV. So this is step up transformer. So when it distributes probably 132 kV, the substation means that here the voltage level has been down, step down. So basically it can be stepped down at 33 kV, at 33 kilovolt. After that, the 33 kilovolt, if we we can either step down one more time for 11 kV or 6.6 kV. Okay, or 6.6 kV. Finally, the 6.6 kV to the 400 or 230, if it's line to line or line to phase voltage. So that is the distribution voltage. So in this example, there are two sections. One is at the substation, another one is at the consumer end. So first of all, we need to calculate the cost till substation. Then we need to calculate the cost till the consumer, till the distribution, line. After that, we will add some profit. The company will add some profit from that on. But first of all, we need to calculate the cost regarding the substation and then the consumer's premises. That means that at the end of the consumers. So at the very beginning, you can see the question is given. Please make questions if you face any difficulties during my explanation. That a generating station has a maximum demand of 75 megawatt, my student. The maximum demand on the generation plant, that is 75 megawatt. 75 megawatt. And the yearly load factor is 40%. That means the load factor on the year is 40%. So generating cost inclusive of station capital cost, it is 60 taka or $60, you can say. Annum means per year per kilowatt demand. Per kilowatt demand, that is 60 taka. And 4 cent or 4 paisa, you can tell, per kilowatt hour transmitter. So that that the maximum demand for the demand it is 60 taka, and 4 paisa it is for per kilowatt hour, the energy consumption. Also, it is given that the annual capital charge for the transmission are 20 lakh, and for distribution, that is 15 lakh. And the diversity factors is 1.2, 1.5. The efficiency of the transmission system is 90%, and the distribution system is 85%. Find the yearly cost per kilowatt demand plus per kilowatt hour supplied at the substation and the consumer. There are so many informations, you might get confused. Okay, before starting, let me divide into two sections. At first, we will discuss at the substation level. At the substation level. So when we are discussing at the substation level, my student, okay, so definitely the distribution will be not included. The distribution will not included. Okay. So first of all, think about substation. When we'll finish at substation, after that we'll discuss about the consumers, that means distribution. So the two information, first of all, that is given, that is 75 megawatt, that is the maximum demand of the generating station, and the load factor 0.4, that is given. So right now we write these two information. Okay. So let's discuss about the what is the cost at the substation level. So definitely we need to find out two costs. One is for fixed, that is per kilowatt, and one is for running cost, that is for kilowatt hour, that means the unit of electricity. Remember, this is two-part tariff. The first part of this tariff is the per kilowatt, and the second part is that the per kilowatt hour, that means the unit of electricity. Okay, that is energy. The first one is the power. Okay, so at the cost of substation, definitely there will be the two types of cost. One is fixed cost. From the fixed cost, we will get the maximum demand or the kilowatt cost, and the running cost will give us the kilowatt hour. So what are the fixed costs given here? First of all, think, what are the fixed costs? You see that it is given here at the very beginning, the 60 taka per kilowatt demand. Okay, 60 taka per kilowatt demand. And what is the maximum demand? That is given here 75 megawatt. So if we just multiply that 60 with the 75 megawatt, 75, if we convert to the kilowatt, because 60 taka is for per kilowatt. So if you just convert the 75 megawatt to 75 into 10 to the power 3 kilowatt, finally we will get that amount of money. That is the for the generation cost, that is already given here. That is the generation cost. Then the transmission cost. The transmission cost is given here 20 lakh. 20 lakh. So we just put that value, the transmission cost. So at the substation level, the cost will be two fixed costs. One is the generation cost, another one is the transmission cost. So these two costs are fixed costs. So if you just sum the two costs, that 4.5 and the 2, finally we will get the total annual fixed cost at the substation level. So in the till substation, we have two costs. One is the transmission cost, one is the generation cost. So we find out the two costs. One is generation cost, and next is the transmission cost. So these two costs will give us the total fixed cost in the substation. So after that, let me go to the next. So till here, you can see that the till here we are. This is in the last page. We have till. This is the same thing in the till. But my student, at the substation, what is the maximum demand? Is it the substation? The maximum demand is the 75? No. You see that in our question, there is a diversity factor given us. The diversity factor that is given us. So the substation level, at the substation level, there are different types of, different substations are connected. There's not only one substation. There are different substations are connected. So if I want to find out the maximum demand on the substation level, that will be not the same in the maximum demand of the generation level, because we all know that the diversity factor equals to the sum of all divided by the maximum demand on that generating station. So the diversity factor is given here 1.2. So we will multiply this 75 in 10 to the power 3 into 1.2. So at the substation level, the maximum demand is that 90 megawatt. Now I'm unmuting my other students. Is it clear, my student? Is it clear that why the substation level, the maximum demand is 90 megawatt, my student? Is it clear?
Yes, sir.
Why, Aziz? Can you just explain to other students why it is 90 megawatts?
Yes, sir. And we can say, sir, we have an annual maximum demand is total of generation. The generation part is 75 megawatt, but we have to find the maximum demand of substation.
Okay.
So we have diversity factor. We multiply that diversity factor into the maximum demand of a generation. Then we will get the maximum demand of substation.
Okay. So basically what he's trying to say that the diversity factor, when it is mentioned, that means that all the substation maximum demand is occurring not at the same time. Okay, not occurring at the same time. That's why if we sum all the substation maximum demand, it will be bigger than the generating station maximum demand. We already solved this type of mathematics, several mathematics. So always remember that when we go for the maximum demand of the power station, that will be always less. But if I discuss the substation maximum demand, because there are several substations and several substations are providing power to several zones, so all the substation level maximum demand will be not the same. So when we sum or aggregate means sum the all maximum demands of the various substations, and the diversity factor is given, so we need to multiply the diversity factor with the available maximum demand of the generating station. So when we multiply with the 75 with 1.2, it is a 90 megawatt, or 90 into 10 to the power 3 kilowatt. So this is the maximum demand at the substation level. Okay, so now we got the total fixed cost 6.5 into 10 to the power 6. We got the total maximum demand. If we divide this 6.5 into 10 to the power 6 divided by 90 into 10 to the power 3, we will get the fixed cost, or the per kilowatt hour cost. So finally, that you see that we just divide the total cost. We just divide the total cost divided by the total amount of maximum demand. So finally, we will get that the per kilowatt, the value is 72 taka, the per kilowatt. So we are not dividing by 75. My students, don't make mistakes. We're not dividing by 75. We are dividing by 90 because the substation has the diversity factor. Okay, this problem is very big, but if we divide the sections, small sections, it will be very easy. Please ask me the questions by unmuting yourself if you face any problem inside the explanation. So this is for the per kilowatt, my students. Another one is left. That is per kilowatt hour. Okay, per kilowatt hour, that is left. We need to find out. And still we are at the substation level, my student. Still we are at the substation level. So the per kilowatt hour, that will be the running cost. Okay, so the running charges, it is given here that 1 kilowatt hour transmitted to the substation, the cost is 4 paisa, or suppose 4 cents. But the transmission efficiency is given here, that is 90%. Suppose that means at the generating station, suppose this is the generating station, this is the substation station. So in between the transmission happens. So in the generating station, they are providing 1 kilowatt hour, but in the substation they are getting 0.9, because the transmission efficiency inside the transmission, that 1% or 10%, that is reduced or loss. So in the generating station they are giving 1 kilowatt, but in the substation they are getting 0.9. They are getting 0.9. So basically the cost, if the substation level they are getting 1, the cost will be same as the generation, but not the generating station, it is 1, but the substation level we are getting 0.9. So that's why the cost should be divided by the 0.9 at that time. So the cost will at the generation at the substation will be 4 divided by 0.9 equals to 4.45 paisa. So it was 4 in the generating station, but when it goes to the substation, it will become 4.45. Why? Because of the transmission efficiency. The transmission efficiency is 90%. If it was 100%, this should be also 4. But now, as the efficiency is not 100%, that is 90% is given here, that's why the cost will be 4.45. So finally, at the substation level, the cost will be 72 taka per kilowatt maximum demand and 4.45 paisa per kilowatt hour. So these are the two per tariff at the substation level, my student. Is there any question till now, my student? Is there any question till now? Please ask me. Is there any question till now? Ahmed, Mahdi, anyone, any question till now? I can discuss one more time. President, President,
Yes, sir.
is there any question till now, my student?
No, sir.
Abbas? Abbas?
Sir, yes. Sir, what does mean by ASA?
Sorry?
We got the 72.22 taka. That's I understand it's money. 4.45 by ASA. What does mean by ASA?
Bias. Bias.
Yes.
What is the meaning of bias?
Yes, sir.
Bias is the 1 taka. Suppose that is the 1 unit. So if you go to the next level, that means a much more smaller level. Suppose paisa is the cent in dollar. In cent, what is the minimum dollar? $1. See, if I want to go much more lower level, then it becomes cent. So paisa is that means paisa. That is not long. That is not available right now in our country. That is the lower level than 1 taka. Have you got it? You can consider paisa as cent.
Yes, sir.
Cent. Suppose $1 is 100 cents. So if I consider $72, that 4.45 is the cent. That 4.45 cent. Is it clear?
Yes.
Yes, sir.
So paisa is the this RS is the rupee in the Indian format, and this paisa is the lower currency, less than rupee, 1 rupee. That's why it is written here paisa. Okay. So now, my students, we already got at the substation level. Now we need to go for the distribution level. Okay, that means the consumers level. So after substation, the distribution line goes. So now whatever the value we got, we need to add more, because to go to the distribution level, our cost will be added. So let's go to the consumers level. So cost at the consumers level, first of all the fixed charge, and then we'll discuss the running charge. So in the fixed charge, now till the substation level 6.5, that was the fixed charge. So when we'll go to the consumer's end, the fixed charge will be added by the distribution cost. The fixed charge will be added by the distribution cost. So the distribution cost was 15 lakh or 1.5 into 10 to the power 6 taka. So we need to add this distribution cost with the cost of substation. Okay, so we just add this. So this becomes 8 into 10 to the power 6, which is the cost, fixed cost till the consumer's end, my students, till the consumer's end. So after that, we got the total amount of cost. Now we need the total maximum demand. If I'm not wrong, till the substation level, the maximum demand was 90 megawatt, but a diversity factor is given here, that is 1.25 in the consumer's level. That means the maximum demand in the substation, it is 90 megawatt, but the amount of consumers are connected with that, their maximum demand will be not 90 megawatt, because everyone has here his individual maximum demand. So if we sum all the individual maximum demand, it will be definitely bigger than the maximum demand on the substation. Why? Because all maximum demand is not happening at the same time. Not happening at the same time. They diverse. That means they're using their maximum demand at different time. That's why the maximum demand in the substation, what we get, that is not the same the maximum demand on the consumers. That is the less value. So to find out the actual maximum demand on the consumers, we just need to multiply with the diversity factor. So if we multiply the diversity factor that is given 1.25, finally we get that is 112.5 megawatt. You see that 112.5 megawatt. We already discussed our previous classes that the maximum demand at the consumer level is the highest. Then the 90 is the substation level. Finally, in the generation level, that is 75, that is given here. So you see that the value is decreasing. Why? Because the maximum demand of using is not happening at the same time. So this is 112.5. This is, at the consumer's level. So we got our cost for 8 into 10 to the power 6. We got our total maximum demand 112.5 into 10 to the power 3. So if we divide this two value, if we, in the next line, if we divide this two value, we find that 71.11 taka, that is for the per kilowatt, that is for the per kilowatt maximum demand in the consumers level. You see that it is less than substation. Why? Because the diversity factor is much bigger than the substation level. That's why the cost also becomes less. This is for the per kilowatt. Now we want to find out for the per kilowatt hour. Now we need to find out the per kilowatt hour, my student. Okay. So from there on, we need to find out the running cost. You see that from the substation, from the substation, it will be distributed to the distribution end, the consumer's end. Now the substation level to the consumer's end, and in between that is the distribution. Okay. You see that the distribution efficiency is 85%. That means 1 kilowatt hour electricity, the consumers will get 0.85. So whatever the cost in the substation level, it will increase in the consumer's level. Why? Because 15% loss at the distribution, because the distribution efficiency is 85%. So we are not getting 100% electricity. That's why this loss cost will be added to the consumers. So we will divide the 4.45 that we got in the substation level. We'll divide that value by 0.85, and whatever the value we get, you see that the cost per substation, that is 4.45 we got. Now we divide that by 0.85, that is 5.25 paisa, that is cent in the consumer's level. So you see that at the consumer's level, when it comes, the value becomes increased, because the loss, the company always take the loss and give to the consumers, because they will not bear the loss. Whatever the loss, they will add that cost into the bill or into the tariff system, and finally make the tariff. So finally we get that in the consumer's level, it is 71 taka. It is 71 taka and 5.2 paisa per kilowatt hour. My student, the important information that should be mentioned, this is not the final tariff. This is the tariff including all costs. This is the tariff including all costs. After that, the company will add a small margin of profit. The company will add a small margin of profit. Then they will offer to the consumers that take our energy, this is our cost, and you have to give that cost. So at that time, suppose this 71 taka will become 80 taka, and 5.23 cent will become that 6 cent. So that small difference is the company's profit. So that is the way of setting the two-part tariff system for a company. So yeah, the questions answer might be very long. First of all, we need to calculate for the substation level, then the consumer's level, but the process is always same. There are two things we need to find out. One is for the kilowatt, that is we'll get from the fixed charge, and one is for the kilowatt hour that we get from the running charge or the running cost. My students, till here, is there any question from your side? I will be happy to answer. Is there any question, my student, from your side? I'll be more than happy to answer you. My student, is there any question? My student, is there any question? Is there any question?
Maybe no, sir.
Still, have you got it? The overall
Yes.
process?
Yes, sir.
Please don't hesitate. If you are facing problem, if you don't understand, please tell me. Because in the online level, I cannot see your face. That's why I cannot predict. But in the when it was the offline campus, I can, I can predict from your face expression. But in the online, I cannot predict. So that's why you need to cooperate with me also. So at that time, I will be, I can repeat or I can discuss that particular point so that you will get, clear. If you don't cooperate, then how can I, understand? Please, if there is no question, that is also okay. But that is not possible in a class. All students cannot be understood. Some parts should be discussed twice. But if it is okay, then I will move forward. But I'm just telling about for your purpose that if you have any problem, if you don't, you can also give me the questions in the privately in the Zoom chat box. If you feel shy, I can also take that question, and don't mentioning your name, I can also discuss. But at least you need to portray the information to me. Okay, please everyone give your role in the chat box, everyone, because last you will get forget. Okay, should I move forward? Can I move forward?
Yes, sir. You can.
Okay. Okay. So everyone give your role in the chat box. You see, my student, it's an interesting question. You see that determine the load factor at which the cost of supplying a unit of electricity from a diesel and from a steam station is the same, will be the same if the annual fixed and running charge are given. So there are two types of power station. One is diesel power station, one is steam power station. Diesel is, that means that it is used by the diesel engine, and there the diesel is used as a fuel. Okay, so here you can understand that there are two types of power station that is given. One is steam and one other one is diesel, and we have to find out that the load factor at which the cost of that both the power station will be equal, same, and their fixed charge and the annual charge is also given here. You see that in the diesel, the fixed charge is 300 taka per kilowatt, and the running charge is suppose 25 cent per kilowatt hour. You see that? And for steam, that is 1200 taka per kilowatt and 6.25 cent per kilowatt hour. So you see that in one diesel, the fixed charge is less, but the running charge is high. But in the steam, the fixed charge is high, the running charge is low. So we need to find out that at which load factor. We know that the load factor is the average demand by the maximum demand. Okay, average demand by the maximum demand, that is the load factor. So we need to find out that load factor according to this information that is given here. Let's start. It's very interesting. Let's start the load factor. So first of all, you see that there is nothing related to given here, that what is the time span, is it the daily or is it the monthly? There is nothing given. So we can take an example. Suppose we take that we are considering 1 year, whole 1 year, and we are finding out the one load factor, and we are also considering there is no number of units of electricity that is given here. So we also take that, suppose 100 units for example. Whatever you take, it will be equal, no problem. Suppose we are taking 100 units of electricity as an example. So this is 100 units of electricity, my student. We'll start our calculations just considering, because we need to find out the information. We need to find that. So first of all, to make the load factor, we take the load factor as L. Suppose for a load factor, we take the value will be L. Okay. So we'll calculate the cost, the fixed cost and running cost for both the diesel station and the steam station separately. So for the diesel station, in a 1 year, the total units of electricity is 100. So what is the average power or the average demand? The average demand, I said that the average demand is the total amount of electricity divided by the number of hours. Okay, for monthly, similarly, the amount of hours that is available in the month. For as we are considering for year, that's why you see that here the 100 kilowatt hour electricity is divided by 8,760 hours. Because this hours is for 1 year, we all know that our total number of hours in 1 year is 8,760 hours. So this is the average power or the average demand. This is the average power or the average demand. Now we need to find out what is the maximum demand. We all know that the load factor L equals to the average demand by the maximum demand. Okay, the average demand by the maximum demand. So to find out the maximum demand, we can take the M here and L here. So that will be the average demand by the load factor. To get the maximum demand, we can take the average demand divided by the load factor. So from here, you can see that the maximum demand will be the average demand by the load factor. You see that the average demand, we just find out 0.0114 divided by the load L. So now we can calculate the fixed charge. You see that here for per kilowatt, that is 300 taka. So we have that this amount of kilowatt. So we just multiply 300 into the total maximum demand that is available in our site. So after multiplying this, this is our fixed charge. Now we will calculate the running charge. In the running charge, we just multiply with the how much units are electricity units, that is 100 kilowatt hour. So 100 kilowatt hour with per kilowatt hour, that is 25 paisa. So that is 0.25. We multiply, that is 25. So for this total cost will be the fixed cost and the running charge. So just we sum these two values. So this is for the diesel station. This is for the diesel station total cost, the fixed cost and the running cost. Now we will calculate for the steam station. Okay, for the steam station. Similarly, in the steam station, my student, it will be just the multiplication. We just already find out the maximum demand. We multiply the 1200 that is given. We got this is the fixed cost and this 6.25 cent for the diesel engine. So you multiply with 100 with the 6.25. Finally, we get that 6.25 taka. So if we sum this fixed and running cost, we get this for the steam station. So finally, it is said that on that particular load factor, the cost of the steam and the diesel will be equal. The cost of the steam and the diesel, it will be equal. So we make the two informations equal and make an equation. From here, if we just calculate from here, we finally get the load factor L equals to a 0.5472. That means the 55.72%. That means the load factor will be the 55.72%. Okay. So basically the question was to find out that load factor at that the total cost of the steam station and the diesel station will be equal. So this was the solve. So I will unmute my other students. Is there any question from your side? You can ask me regarding this problem. My student, Is there any questions or any part I will discuss one more time? My students, please share, give your feedback. Kafu, are you here, Kafu? Kafu? Kafu,
Yes, sir. Yes.
are you here?
Yes, sir. Yes.
Is there any question from this example?
No.
Hassan? 38, roll 38, Hassan. Hassan? Probably he is not here. Abdul Kader Harare. Abdul Kader Harare. Abdul Kader Harare. Can you hear me? Omar Farooq.
Sir, Assalamualaikum.
ওয়ালাইকুম সালাম। ওমর কোনো কোয়েশ্চেন আছে?
No, sir.
তুমি সত্যি বুঝতে পারছো নাকি এমনি বলতেছো না? সত্যি কথা বলো তো।
স্যার প্রথম দিকে স্যার হচ্ছে দেখি নাই, পরে হচ্ছে স্যার দেখছি।
এইটা কি বুঝতে পারছো? মনিমা কি আছো? মনিমা
স্যার আছে স্যার।
তুমি কি সত্যি বুঝতে পারছো নাকি বলতেছো না? সত্যি কথা বলো তো, আমি কিন্তু কনফিউজ, তোমাদের ক্লাস আমি কনফিউজ, কেউ কোনো রেসপন্স করে না।
অনেকক্ষণ ছিলাম না স্যার, নেটের প্রবলেমের জন্য অনেকক্ষণ দেখতেই পারিনি।
আচ্ছা, নাজিফা কি আছো? নাজিফা?
জি স্যার, জি স্যার, আমি আছি।
তুমি কি আছো? আচ্ছা, তুমি আমাকে ইনফরমেশনটা বলো যে তোমরা কি আদৌ বুঝতে পারতেছো নাকি আমি কি ধরে নিব? কি কোনো ফিডব্যাক পাই না তো নাজিফা? আমি
বুঝতে পারতেছি তো, সমস্যা হয় না। আর যদি কোনো প্রবলেম হয় তারপর হচ্ছে নেক্সট।
এরা কি সবসময় সব ক্লাসে এরকমই করে নাকি আমার ক্লাসে শুধু এরকম? নাজিফা
সবাই এরকমই হচ্ছে, আমার হচ্ছে গিয়ে স্যার অনলাইন ক্লাসে তো আমি বুঝতে পারি সবাই ফিডব্যাক চায়, নাহলে বুঝতে পারে না টিচাররা যে অ্যাকচুয়ালি আমরা বুঝতেছি না।
আমি তো বুঝতেছি না, সত্যি বুঝতেছি না আমি যে অ্যাকচুয়ালি। Aziz, Abdi Aziz.
Yes, sir.
Is there any question from your side, my student?
স্যার হচ্ছে
No, sir.
হচ্ছে আমি
হ্যাঁ, tell.
RS ইউজ করে, বাট সবার লাস্টের যেটার মধ্যে রেজাল্টটা পাচ্ছে ওটার মধ্যে আর ইউজ করে। RS আর RE দিয়ে কি বোঝায় স্যার?
ওই RS RE দেখলা, আমি একটু দেখে নিই।
স্যার এইটা না হচ্ছে আগের দিনে ছিল
আগে এক্সাম্পলে না?
জি স্যার।
তো এখানে RS তো লেখা আছে, RE কোথায়?
আচ্ছা, আগের দিনের যেগুলো সলভ করেছিলেন।
আচ্ছা, আগের দিনে যেগুলো না?
জি স্যার। এই যে স্যার RE আছে লাস্টেরটা যে কস্ট।
আচ্ছা, এইটা মেবি তোমার ওদের কারেন্সি রিলেটেড। এটা আসলে অ্যাকচুয়ালি কোনো কিছু এখানে এটা ম্যাথমেটিক্স এর রিলেটেড না, এটা ওদের কারেন্সি রিলেটেড কিছু হতে পারে। RS RE I have no idea about Indian currency, but এটা অ্যাকচুয়ালি কারেন্সি রিলেটেড, বুঝছো? এটা আমাদের ম্যাথমেটিক্স রিলেটেড কোনো কিছু না। দেখো ওদের যে পয়সাটা, আমাদের দেশের যে টাকা মানে পয়সা সেম, ঠিক আছে? ইভেন সেন্ট, ডলার যে সেন্ট, ওইটাও কিন্তু $1 = 100 সেন্ট। তো এটা টোটালি কারেন্সি রিলেটেড। এখানে কোনো মানে এটা কোনো ম্যাথমেটিক্যাল এক্সপ্লেনেশন কিছু নাই। হয়তোবা RE আই ডোন্ট নো, টোটালি কারেন্সি রিলেটেড। এটাতে মানে এমন কিছু নাই যে এটার মধ্যে এমন কোনো রহস্য লুকিয়ে আছে, এটা কিছু না, টোটালি কারেন্সি রিলেটেড। ইউ জাস্ট অ্যাভয়েড RS RE, জাস্ট তুমি থিঙ্ক করো টাকা বা ডলার। বুঝাইতে পারছি? এটা নিয়ে এটা কোনো ইয়েতেই না। বাট স্টিল RE লিখে একটু সার্চ দিও তো। RS মানে তো রুপি বুঝতেছি, বাট RE মানেও রুপির কোন একটা ভার্সন হবে, এটা একটু জাস্ট দেখো। হয়তো বা দশমিকে গেলে ওরা RE লেখে কিনা, মানে দশমিকে যখন যায় সেটাকে ওরা RE লেখে কিনা, এটা আমি মানে পয়সাকে হয়তো বা ওরা দশমিকে গেলে মনে হয় RE লেখে, এরকম কিছু হতে পারে। একটু দেখো, হ্যাঁ? আমি যদি জানতে পারি আমি তো তোমাদের জানাই দিব। My students, is there any question from your side? I am getting confused. Abdi Aziz, help me.
Maybe not, sir. All the students, they are silent here. And if any person who is going with the lessons or the examples, maybe if he confused any party, he will ask you. But
okay,
I don't know.
Ahmed Mahdi,
yes, sir.
Please.
Yes, sir.
My explanation was enough to understand, or
yes, Yes, sir. Yes,
Have you
sir.
got it? Have you got it?
Yes, sir. I
Okay,
got it.
okay,
Very
okay.
clear.
I will check this that my student that yeah you got it. That was quite positive use. But please don't hesitate to inform me that uh, please discuss this topic one more time, because this course is full of mathematics, my student. So definitely we all know that this type of mathematics, when we solve in our whiteboard and marker, it will be much more fruitful, much more helpful for others. But as there is no not, it is not available right now, but still we need to cooperate because this is pandemic
Sir,
time.
where is the midterm result?
Sorry,
Said, sir, where is the midterm result?
midterm results. Midterm results are available. I will give you when the department will say, but don't need to what can I say, don't need to worry about that. Don't need to worry about that. You have everyone have done well. Okay. I will ask that if I am allowed to give you when the chairman sir will say, then I will give, no problem. Okay. So that was it. That was it for today's side. Today we'll discuss the next class. We will discuss 3-4 more mathematics. So just for in the next slide or in the next coming classes, we'll discuss about the power factor also. That how the power factor can also have an effect on the tariff system, because we also discussed one tariff system that is related to power factor tariff system. So how that helps or how that incorporates with the tariff system, we'll also discuss in the next class. But if I think that everyone has given role, let me check one more time for the attendance. It is the roll number 20, roll number 1, roll number 45, roll 4, roll 50, roll 32, roll 21, roll 12, roll 7, roll 11, roll 39, roll 14, roll 34, roll 40. Please, if anyone is missing, please give your roll in the chat box. Please, my student, if anyone is missing here, give your roll in the chat box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total 15 students have given the role. If anyone is left, please give your role in the chat box. I think that all has given. So my student, that was for today's class. In the next class, we'll discuss 3-4 more mathematics related to tariff system, and inshallah we'll complete that chapter from here. And after that, we have one more topic left, that is power factor improvement. We'll discuss that, and that will be our end of this course. In this course, we discussed the two important power station. One is hydroelectric power station in details. Another one is nuclear power station. My students, in the basic mechanical engineering, we have discussed the steam power station, the gas turbine power station. So that's why I haven't repeated those things in this power station, in this courses. So we discussed the nuclear power station and the hydroelectric power station. Very, I know. So in the next we discuss the variable load of the power station, where we discuss different important parameters, suppose maximum demand, maximum load factor, diversity factor, the capacity factor, and according we have solved several mathematics. After that, we started the tariff system. We have discussed till today probably 6 to 7 mathematics. Inshallah, after that, we'll also discuss some 3 or 4 or 5 mathematics. After that, we'll discuss the power factor improvement. So that was the overall course of the power station. The course was fully based on mathematics. So I will tell all my students, please try to solve, because there are so many mathematics. So if you don't practice by your hand, it will be very tough for all of you. So I will request to all of my students, please give your effort by solving whatever I showed you to mathematics. These tools are very big mathematics. That's why I didn't try to incorporate other topics, so that will confuse you today. So please try to solve by yourself. Try to give practice. That will help you. So today I will not talk. If any students have any questions, he can stay I'm here, but if you have no questions, you can go. You can leave.
Sir,
Yes,
sir,
please, Aziz, please.
sir, and the distribution, DC distribution and AC distribution is very important, sir. But
Yeah.
in the previous semesters we did not take, and this is the end of semesters. The semester 12 only we have one course, and we will not take that one. So how can we cover that?
It's a very critical questions that you asked me. But how can I help you in this section? Suppose that topic was basically distribution. That was a dedicated course, transmission and distribution of electric power, isn't it?
Yes.
So I tried in my course, I tried to cover maximum, at least 90%. Those topics are very important, and will be, if you don't know that those topics, you know, there will be some shortage of your knowledge. So I try
Yes.
my best. You know, please definitely contact. Which teacher has taken that course, Aziz?
Fabliha, Madam Fabliha.
So I do not take that course, the transmission and distribution of electric power. Probably you have studied the SAG.
Yes. Only
SAG.
transmission part. We have completed transmission part. But distribution part, voltage control, DC distribution, AC distribution, we did not have any idea.
So you didn't ask that madam, that's madam, we are left a huge amount of you know, syllabus. You didn't ask.
At that time, sir, we were juniors, so we did not know which topic is very important to which topic is not. So that's a big problem, sir.
Okay. So on that note, you can tell your coordinator, sir, probably a night, sir. Okay. Probably he can, you know, give you some, because this course, if I'm not wrong, this course is taken currently by Tafsir Ahmed Khan sir, by Naushad Ahmed sir. So if they voluntarily take you one or two chapters, one classes each, so I think that those topics can be covered. Okay.
Yes.
So what can I say else?
Probably. No problem, sir. No problem.
But yeah, definitely this is important, because the distribution side was important. You can discuss with an sir. If he do not give the solution, at that time you also discuss again me. If I get the opportunity, I will discuss one or two chapters after this semester, probably, but not inside this semester, because right now the course pressure is too much. But in the 12th semester, when you go there, if you are still interested, I can take one or two classes for that voluntarily. Also for that, I also need to study, because you also need to give me sometimes, because I didn't take that course. So the course material is not available to me. So I need to study. I will study first, then I will discuss too. If you are still interested, sir, we want to know that topic, then I can help from my side voluntarily. But you know, that course, I do not take that course. But still, if you are interested, and if you don't find the solution still, by contacting your coordinator, sir, and tell him, explain the things. Okay.
Okay, sir. Thank you, sir.
But still, it is not finished. Still, the Tafsir Ahmed Khan sir is in your course teacher, one of the course teacher, isn't it?
Yes.
So you can also discuss with him, because he takes the power transmission and distribution course in other batches also. So let's see what he says. If he accepts to take one or two classes, it will be helpful. Okay.
Okay.
Okay. Thank you, my students.